Logarithmic equations. Equations that contain logarithms are called logarithmic equations. In the expression log base a of m is called the input of the logarithm, and a is the base of the logarithm. Remember, input of the logarithm must be positive. That is, you can only take the logarithm of positive numbers. You cannot take the logarithm of a negative number. If you try that with a calculator, you're going to end up with an error. As for the base of the logarithm, it must also be positive, and the base cannot be 1. Now, when you solve logarithm equations, be sure to check your solution, right? That is, take the value of the variable, plug it into the original problem, and make sure it satisfies the condition. If it doesn't satisfy the condition, then we have what we call extraneous solution at that x value, or at that value of the variable. Now, some logarithms can be solved by changing the logarithmic equations to exponential form using the fact that y equals log base a of x, which basically means a raised to this power equals x. And that usually happens when you have one logarithm involved. So let's look at the strategies or the steps on how to solve logarithm equations. So step number 1 is you want to move all the logarithms to the left side. Step 2, write the left side as a single logarithm. And then step 3, we're going to convert the equation to an exponential form. Step 4, solve the equation for the variable. And then step 5, this we have to always do, is check the answer in the original equation. So we must follow those 5 steps when solving logarithm equations. Now, let's take a look at the first example here. We have a logarithm base 3 of 4x minus 7 that is equal to 2. How do we solve this equation for x? Well, remember, inverse of a logarithm is exponential. So in this case, we cannot divide by the log base 3. A lot of students do make that mistake. You cannot divide by the logarithm of the base. So what we're going to do in order to solve this equation is we're going to convert this into the exponential form. So let's bring down the equation. Let's convert this to the exponential form by taking the base of the logarithm raised to this power must be equal to this 4x minus 7. And then from here, we just simplify the exponential portion. 3 squared is 9. Now from here, we can add 7. You get 4x equals 16. Divide both sides by 4. I get x equals 4. 4 is the potential answer, right? Now let's check. We have to substitute 4 for x in the original equation. So if I replace my x by 4, I get the logarithm base 3 of 4 times 4 minus 7 equals 2. Let's simplify what's inside the parentheses. 4 times 4 is 16, minus 7 is 9, so you get the logarithm base 3 of 9 equals 2. Well, 9 could be written as 3 squared. Now, as long as the base of the logarithm and this base right here, that 3, are the same, your solution on this end would be 2. So you get 2 equals 2. Or you can use a calculator, right? Convert this into the exponential form, which would be written as 3 squared is equal to 9. And we know that 3 squared equals 9. So in this case, that satisfies the condition. So that means x equals 4 is a solution to example 1. Example 2, we have the following equation. Our unknown variable in this case is our base. Remember, the definition of the logarithm states that the base of the logarithm must be positive but not equal to 1. Okay, so in order to solve this equation, we're going to convert this to the exponential form first by taking the base of the logarithm raised to this power is equal to 64. And then from here, we can take the square root on both ends. So if you take the square root on both ends, you get x equals plus or minus 64, which simplifies into x equals plus or minus 8. Now, the definition tells us that the base must be positive but not equal to 1. So therefore, our only possible answer in this case would be x equals 8. X equals negative 8 would be the extraneous solution. Let's check. Plug in positive 8 for x. You get this. From here, you can apply that change base formula. That is, take the logarithm of 64 and divide it by the logarithm of 8 using a calculator. This side should turn out to be a 2. And then, of course, equals 2, which works. Or you can convert this to the exponential form by taking the base raised to this power and see if it's equal to that number. Well, we know that 8 squared equals 64, and therefore the solution in this case would be 8. All right, example 3, we have this equation here. We're going to apply the same techniques here. So to solve this equation, first I'm going to get rid of that fraction 1/2. So in order to get rid of that 1/2, I can either divide both sides by half or multiply both sides by 2, right? And then we're going to convert that into the exponential form. So let's go ahead and look at the equation here. Multiply both sides by 2. 2 times half, or 2 halves, make a whole, and 1 times that logarithm base 5 of, basically 1 times the left hand side would be just the left hand side, what you have there. So we get this. Now, once the logarithm is isolated and it equals a number, convert that into the exponential form using the definition of that logarithm, right? Log base a of x is equal to y if and only if a to the y equals x. So basically, you take the base of the logarithm, raise it to this y, and then set it equal to what's inside the parentheses. So in this case, 5 to the 4 is going to be equal to 2x plus 5. And it doesn't matter position-wise. You can have the 5 to the 4 on this side or that 2x plus 5 on this side. Now we can simplify this. 5 to the 4 is 625. Subtract 5 on both ends. You get 2x equals 620. And then divide both sides by 2 to isolate the variable x. So you get x equals 310. Well, we have to always remember to check our solution, right? And if you plug it in, it should make sense. In this example, we have a logarithm equals a number. So what we can do here is we can convert it to the exponential form by doing that. Base of the logarithm raised to this power must be equal to 4x plus 11. So in this case, 4x plus 11 equals 5 squared. Well, 5 squared is equal to 25, so we can do this and then subtract 11 on both ends to get 4x equals 14. To isolate the variable x, divide both sides by 4 since we're multiplying over here. Inverse of multiplication is division, so you get x equals 3.5. So the possible answer in this case would be 3.5. Let's check. Well, if we substitute 3.5 for x in the original problem, this is what we get. 4 times 3.5 is 14. Simplify what's inside the parentheses, you get 25. We can apply the change base formula here. The left-hand side could be written as this, and then if you use a calculator, you should get 2 equals 2. So that means our final answer in this case is x equals 3.5. For this example 5 here, we have multiple logarithms with multiple variables. So how do we solve for the variable m? Well, in order to solve this equation for the variable m, we need to isolate the logarithm with the variable m. So I'll subtract the log of y to the other side. We get the following. And then what we're going to do here is usually when you have multiple logarithms on one side, you need to condense that. That is, rewrite it in a single logarithm. So first thing we're going to do is apply this property right here. That is, if you have a logarithm of x to the a, that is equal to a times the logarithm of x. What we have on this in this logarithm here is this condition right here. So I need to rewrite this in terms of this, which means you take the coefficients here and put it as an exponent here. So that will give you the following condition here. Now from here we can apply that subtraction or the quotient property, which states that if you have two logarithms that are being subtracted, you can condense that or rewrite it as a single logarithm by dividing what's inside the parentheses. So applying this condition here, this right-hand side could be written as the logarithm of x to the 2/3 divided by the y, as following. Now, what you notice here on both ends is we have the logarithm of this equals the logarithm of this, which we can apply this condition here. If you have a logarithm of x equals a logarithm of y, then x must be equal to y, right? If those two the only way those two conditions could be equal to one another is if what's inside the parentheses are the same, because logarithm wise they're both the same. So what we can do here is basically drop this logarithm condition, so you get m equals x to the 2x divided by y. Example number 6, we have multiple logarithms on the left hand side, and that is equal to 1. So first of all, remember, what goes inside the parentheses needs to make this expression here inside the parentheses positive, right? We want x plus 6 to be bigger than 0. The reason is that you cannot take the logarithm of negative numbers. So we want to come up with those x values that would make this expression here positive, bigger than 0. And the same over here. We have to say x plus 2 is bigger than 0. That is, find the x values that would make this positive. So in this case, what we're saying is, well, the x that we're going to come up with must be bigger than negative 6, and it also must be bigger than negative 2. So let's go ahead and go through the process here. So we're going to apply that addition property or the product property. If you're adding two logarithms, you can condense that into a single logarithm by applying this condition here, by multiplying what's inside the parentheses basically. And then from here we can apply that change base formula, where that we can change this into the exponential form by taking the base of the logarithm raised to this power must be equal to what I have inside the bracket here. And we know that 5 to the 1 is equal to 5. So in this case, we have x squared plus 8x plus 12 is equal to 5. Well, this right here is what you get when you FOIL this, right? X times x is x squared. 6 times 2 is 12. And then you have x times 2 is 2x, and 6 times x is 6x. And if you combine those two, you get the 8x. So the only way to see this is if you FOIL this. And then we can subtract that 5 over to the other side to get this. And then from here, we can factor this, right? Because the coefficient here is 1, all I need to find is two numbers that multiply to 7, but then add up to 8. And the two numbers that multiply to 7 and add up to 8 are 7 and 1. So that would be written as x plus 7 times x plus 1 is equal to 0. And by the zero product property, if you multiply two numbers and you get a 0, at least one of them must be equal to 0. So we're going to set each factor equal to 0 and then solve for x. So x plus 7 is equal to 0. Well, that would give you a negative 7, and this will also give you a negative 1. Now, the potential answers here are negative 7 or negative 1. Well, remember, the biggest number I have here is x is bigger than -2. So I want my x value to be bigger than -2. Well, the only number that's bigger than -2 in this case is then -1. What happens if x equals -7? Well, I'll plug a -7 here. -7 plus 6 is -1, and you can't take the logarithm of a -1. Well, what if I plug it in here? You still get a negative number. What if x equals -1? Well, plug it in here. -1 plus 6 is 5, which is positive. And -1 plus 2 is also positive, so that satisfies the condition. So the only answer that satisfies this equation would be x equals -1. And x equals -7 is what we call the extraneous solution, so it cannot be a solution. Okay, in this example, let's take a look at what happens when you have multiple logarithms on one side. Well, first thing you want to do is you want to condense that left-hand side. And to do that, we have to apply the subtraction or division property, which states that if you have a logarithm m minus a logarithm n, we can write this as a single logarithm by just dividing what's inside the parentheses, right? Log of m divided by n. So applying that property right here, we get the following equation. We can then state that according to this property right here, if you have a logarithm x equals a logarithm y, well, the only way those two could be equal is if x equals y. That is, if what's inside the parentheses are equal. So for those two to be equal, what's inside the parentheses must be equal as well. So we set what's inside the parentheses equal to one another. Now we can multiply both sides by 2x minus 3, and that is to get rid of this denominator right here. And what I'm left with on the left-hand side is x minus 2 equals, on the right-hand side, we have to distribute the 2. 2 times 2x is 4x, and 2 times -3 is -6. So you get this equation here. Now let's move the constants over to the left side by adding 6. I get x plus 4 is equal to 4x. Now we're going to move the x's to the same side, so let's move this x over to the right side by subtracting. 4 equals 3x, and finally we can divide by 3 to get the x value. So x equals 4/3 is the possible answer. Well, since we're solving logarithm equations, we need to check our solution. So let's go ahead and plug in 4/3 for x. Now, 4/3 minus 2, that gives you -2/3. That's a problem, since we can't take the logarithm of a negative number. X equals 4/3 is not a solution. Even though it works here, it does not work in this logarithm. So we cannot take that 4/3 as a solution. So this problem has no solution in this case.